this is bad. Oh, darn it. Okay, I'm recording. I forgot that first one though. Sorry. Okay, so we get 8.5 times 9.
This is why we get to do it.
Yeah.
Oh,
76.5. Okay, but hold on now. Let's try that. Let's try that. Let's put in 70. Oops. $76.5 meters. All right, let's try it out. Oh man, what happened? I even included some feedback for you here. How cool is this? You didn't include the correct number of significant digits. How many should I keep? 2, because I'm doing a product, right? I'm doing it. Does that make sense? And my least, I only have 2 sig figs in those 2 measurements, 3 in that one, but I got to keep the least number. So that's got to get rounded back to 77 meters. There we go. How about that? Okay, make sense? Okay.
So why didn't you want us to answer it exactly?
Because these are presumed to be measurements. And so, because I'm only keeping 2 sig figs there and there, keeping 76.5 assumes that we had more precision on those than we actually did. So you remember that was one of the earlier assignments where you guys had to do those calculations involving sig figs, right? What's our rule when we're adding or subtracting? We just keep the least precise column, right? But rarely do we do that. Usually we're doing physics, we're multiplying and dividing and things like that. Whenever we do some kind of a complicated computation that involves more than just adding or subtracting, then we have to get our answer and round it to the least number of sig figs, right? Okay? So that actually gave us partial credit. It probably gives you 90% or something, but it doesn't give you full credit because it's not rounded properly, okay? All right, so let's try another one. Let's try this guy, how about?
I like the way they changed it with the new format.
For Moodle?
Yeah,
it's pretty slick. Oh, I'll tell you what's really cool with this. Watch this. I've been working with these guys in Spain. This is really cool. If you use this thing, have you seen this before? Like I can say x plus y squared, and then I go, okay, look what it does. What? Isn't that incredible? And so, oh, I should put that in here. How come it didn't? Uh-oh.
Guys in Spain.
Okay, so
Spain.
I messed up the whole program.
I did.
Call him right now.
Oh, I'll be emailing them.
Like, hold on.
So, I think that's the way it's supposed to be, though.
Try putting in the correct answer and then being simple.
Oh.
Because when you click on the little box, it brought you up to this. So
Okay. Good point. Okay, so let's junk that. And what is, okay, well, we'll have to figure out what the answer is supposed to be.
Yeah.
Okay. So
Probably just have
let's,
to refresh it.
Yeah, just press check. See if it gets no hands.
so I should be able to, and how do I go back? Oh, there we go. Go to that. There we go. So now, yeah, just gotta. Okay. There we go. We're back. Back in business. So we'll try. I'm gonna try it with the right answer. See if it works. But we got to get the right answer first. So what information are we given here? Let's see.
We're given average velocity.
Okay. Now read this one. So before I start blabbing on here, just read this for a second and try to digest it. Think about this problem for a second. There's something a little trickier about this one. Now, what are we going to do? So, here's some good stuff. So what's going on with this problem?
So you have to find the average velocity.
Okay, let me ask you this, how many parts are there to
So
this?
there's two parts, but, so we just need to work with the 8.5, so just do all the same calculations.
Okay, so I want you to see this, this is kind of, and this will come up again and again in physics. What we're gonna find, does it make sense to you that there's two discrete parts to this? There's kind of the part one where we're uniformly accelerating for 8.5 seconds, and then part two, where we're gonna continue at that constant speed for 6.5 seconds. Does it make sense that there's no one equation that's gonna handle that whole thing at once? Right, we gotta deal with this in two parts. In general, what you're gonna find, and this will make more sense as we go through this, is that anytime you're dealing with a physical situation like this where the acceleration changes, you've gotta break it into multiple parts, okay? And so the acceleration, we had some acceleration here. What's my acceleration when I'm traveling at constant speed?
Six.
Acceleration.
Oh,
Zero, right? So my acceleration went from some positive value to zero, so I gotta break it into two parts. So let's do part one. So for part one, what can you tell me? Starting velocity. Okay, so V naught is zero. Okay, what else? Final velocity is 6.0. Okay, what else? Time equals 8.5. And we're trying to find what for this problem? Okay, good. So we're going to need average velocity, but our goal that we're trying to answer for part one and part two is what is the displacement, and then we'll just add those two answers up, right? Does that make sense? So we're trying to find, we'll call this delta D sub 1 for part one. Okay, that's what we're trying to find. Okay, but to get there, Kate already saw that we don't have an average velocity yet. That's necessary for us, right, at this point. Later on, we'll have a different kind of equation that'll allow us to maybe even bypass that. But for now, what we've got requires, say it again? Yeah, there is. I'm not gonna give it to you yet. It's a longer kinematics equation. We'll get to that soon. Next chapter. So what is our average velocity then? 3. Okay? And so now we've got all the information we need to solve for the part one displacer, right? What's the equation I'm gonna use? Okay, equals average velocity times time, which is equal to what? 3.0 times 8.5? And so what do we get? What is it again? 25.5, okay.
Do we want to use sig fig then, or we shouldn't round yet, right?
Yeah.
Okay, we don't need to round yet, do we? Right. Okay. Okay. 25.5 is part one. Now let's go to part two. Okay, part two should be easier. What's part two?
6 times 6.5.
Okay, so what do we know about part two? Okay, we know the velocity is constant, isn't it? Right. So if it's constant, then it's its own average, isn't it? Does that make sense? If I start with a velocity of 6 and I end with a velocity of 6, what's my average velocity? 6, right? So we could even call that, if we want to, we could even call that V bar. And they give us that directly. And the time is 6.5 seconds, right? And so we can do the same thing. Delta D sub 2 just equals 6.0 times 6.5, which is what? 39, okay? So now if I add those up, 25.5 plus 39 is what? 64.5?
Yeah.
Okay, but I have to keep 2, so what am I gonna put in? 65. Okay. Oh, that's right. Okay.
So it's basically just like doing the same problem twice.
Like it, I guess. We'll see if it works.
It's not going to.
Wait,
So
just
you
check
check
it,
before-
check it.
Oh,
No, just
No, no,
check.
Oh.
Go
okay.
And then click check.
And then click check.
It's not.
Oh, man, that's amazing. It didn't show up. I don't know. I'll have to ask him about that. I don't know why it's not showing up. But
If you, I think if you go like back to the original screen, because then it'll input it into like.
oh, yeah. There you
and
go.
then it'll.
Oh, yeah. Okay, so now if we just go back
Yeah,
to
the keys,
that.
and then hit okay.
There we go.
That's all.
Nice. All right. Okay. Oh, I knew I kept you guys around for some reason here. Okay, so how about one like this?
Oh, this is hard. Yeah.
How come NA?
We don't have time.
We don't have time. Yeah, we have enough information to find an average velocity, but in order for us to find displacement, we have to know how long it's traveling, right, at that average velocity, right? Okay. Do you see that that would make a big difference? If I accelerated from 0 to 33 meters per second in 1 second, I'm not going to go very far, right? But if it takes me 100 seconds to accelerate from 0 to 33, I go a lot further, right? Okay. So yeah, that one's. Let's try it. See if we can put it through the paces here. This is kind of fun.
There you go.
That's a good one.
It's not at the top.
There you go.
What are the sign of acceleration questions?
Okay. So these are easy. All these are, for example, stuff like this. Slowing down while traveling along the x-axis in the negative direction means what? So it's kind of the stuff we did at the front of the room. Okay? That make sense? All right. Want to work?
Yeah, be
Okay.
positive.
I'll get Chromebooks.
I don't understand.
If it's.
I just